I'm Scott Simi, Chief Content Editor with InDro Robotics, and joining me on today's edition of our Soundbite micro podcast is InDro's Head of R&D Sales, Luke Corbeth. Welcome, Luke.
Thanks for having me again, Scott.
All right, the topic of the day is the power of advanced teleoperations in robotics. So let's start with the basics. What does teleoperation mean?
Yeah, so teleoperation is the capacity to remotely operate a system. Now, this could be a drone, it could be a ground vehicle, but it requires the operator to have real-time command and control and visualization of all of the system's payloads.
We now have public and private 5G networks available, so what difference have those made to capabilities? And I'm talking here in terms of data bandwidth and also, I suppose, robustness.
Yeah, so 5G networks really are an enabling technology for robotics. They provide ultra high bandwidth, low latency, and enable real-time transmission of large volumes of data from sensors like HD cameras and LiDAR, for instance. When looking at private 5G relative to public 5G, they really ensure more robust, secure connections with minimal interference, improved security, enhanced reliability for critical operations, and most importantly, the capacity to kind of customize and prioritize certain connections when solutions are active.
Now, you just kind of touched on it there, but let's say we've got a remote robot with multiple sensors, optical, thermal, LiDAR, depth cameras, the whole nine yards. So are you saying that all of that data could be handled in real time, meaning someone monitoring the system could see everything at once? Is that a fair assumption?
Absolutely. This wide bandwidth supports simultaneous streaming of high resolution data from multiple sensors like the ones you've highlighted there. And this allows, real-time processing and decision-making for complex robotics tasks, but also allows for the control of these payloads. And all of that data can then be uploaded where it's needed to reporting software and ERP or anything else like that.
And because these networks are now pretty ubiquitous with rare exceptions, remote operations, I'm guessing, could be truly remote. True or false?
That's true. With 5G's near ubiquitous coverage, robots can operate remotely from virtually anywhere with minimal latency. This really enables that seamless control I was speaking about and allows the capacity to monitor across, really large geographies. This, alongside other technologies like wireless charging, are foundational for that no human in the loop value proposition that many organizations are looking to adopt.
So we've got remote teleoperation, we've got high bandwidth. So what type of use cases would really benefit?
Use cases like remote critical infrastructure inspections, precision agriculture, search and rescue, and even something like inventory counting would benefit immensely. You can then extend this to other things like delivery, security, and surveillance applications. And those can be the main use case or an ancillary use case. This means these technologies can now be useful across many verticals. We're talking mining, utilities, solar, nuclear, agriculture, for ports or railways, just to name a few.
I know, for example, we have Sentinels, our flagship inspection robot, deployed in the US doing remote monitoring at a large facility. Are these autonomous inspections?
Yeah, autonomous and teleoperated. So Sentinels tend to live on site and, they come out of their enclosure to perform autonomous inspections. They're navigating predefined routes and collecting data from the multiple sensors equipped. But when pairing this with its teleoperation capability, we can really reduce the need for human intervention by giving top technicians and operators that telepresence on site to check when an anomaly is flagged in an autonomous mission, what is exactly going wrong and what resources need to be deployed to solve that problem.
Now, just because we have the capability for remote operations, that doesn't mean that they have to be remote, correct?
Yeah, that's correct. When bringing on technologies like this, especially for that first initial deployment, we actually suggest that they're relatively close by, somewhere with easy access and ideal connectivity environment to help kind of flatten the learning curve and ensure they're successful with that first deployment. But also, this can extend to indoor applications. So if you look at, warehouse applications, for instance, especially on the private 5G side of things, something like that isn't truly fully remote.
Cool. So we have autonomous robots and even drones with sensor fusion running these remotely teleoperated missions. How are these missions controlled?
Yeah, so all of the missions on our systems are managed through InDro controller. Now that's our intuitive software suite. It allows the users to monitor, teleoperate, plan, observe, and then manage the data that's ultimately captured in both autonomous and teleoperated missions. Not to mention, it also gives us the ability to troubleshoot should something go wrong, or update the robot remotely whenever we have new updates to help maximize its uptime and improve its performance.
Now, I've seen a demo of InDro controller. Obviously, I'm not an engineer, but it looked pretty intuitive to me. So I guess the question is, how easily could someone set up a repeatable autonomous mission?
I'm not an engineer either, but it is relatively straightforward. The user-friendly interface makes it as simple as possible. We want to keep the barriers to entry, as low as possible. So users on the autonomy side can define waypoints, set sensor parameters, schedule missions to run. There's a bunch of drag and drop tools and customizable interfaces. And then on the teleoperation side, we just use something as simple as an Xbox controller in most cases, because this familiar form factor, we found it only takes, operators who are new to using it a couple of minutes on the sticks before, they feel comfortable operating the system at a pretty high level.
Now, let's say there's some critical asset that I want to keep a close eye on, say a pressure gauge or a component that needs to always be operating within a critical thermal range. Can controller be set up to autonomously look at these items each and every time?
Yeah, we can autonomously focus on, specific assets. That's a key part of our, setup process when we initially get the robot on site. We can look at things like pressure gauges, thermal critical components, like you mentioned, during every mission, and capture really detailed data with precision and consistency. And then through techniques like machine vision, we can train models to basically digitize this information and then ping or issue a webhook to asset owner operators when certain anomalies are detected.
Now, the other thing worth mentioning is that we've put a lot of work into our new InDro Cortex, and we're all pretty excited about it. Tell us about what it is and how it will enhance remote teleoperation and sensor integration.
Absolutely. So InDro Cortex is kind of the brain box of the future for our organization, and how we're helping other companies as well build out smart AI capable robots. It's optimized both in terms of its weight and design to go onto drones and robots. Allows for data processing, real-time decision making, and seamlessly integrates onto a wide range of platforms, but is also compatible across a wide range of payloads as well.
InDro currently does have autonomous deployments with clients, which we can't unfortunately reveal publicly yet, but it's starting to feel like industry is really kind of grasping the power and potential of autonomous robotic teleoperations, whether they're remote or inside a massive building. Would you agree with that you've seen kind of a shift in interest?
I absolutely agree. I think people are becoming more aware given the recent advancements in AI. But those adopting autonomy and teleoperations do it for efficiency, safety, and scalability. I feel a lot of them are recognizing their potential to transform operations in these diverse settings, anywhere from remote sites to large facilities, as you highlighted. I think this is particularly important for companies trying to scale, compete globally. Any organization that cares a lot about their data security and data collection, the power is in the data these days, and especially those with hiring challenges, as it can make a few workers really have a true global presence, or at least a presence across the country if that's needed.
Awesome. Anything else you'd like to add, Luke?
Just that InDro Robotics is committed to, pushing the boundaries of autonomous operations and teleoperations with both drones and robots. And we're going to keep delivering solutions that empower such a wide range of industries to operate smarter, safer, and more sustainably.
Luke Corbeth, head of R&D sales with InDro Robotics. Thanks for your time, and as always, a pleasure to speak with you.
Pleasure is mine, Scott. Thank you.